In today's lecture, we are going to discuss about scheduling algorithm. Scheduling algorithm. Right? We have already discussed about what is algorithm. We all know. Algorithm is what? It's a step-by-step execution of any problem. Now, before that, we have to understand that CPU scheduler execute the job when they schedules on it. See, every processor execute the job. How can you execute a job unless it is not scheduled on it? So the CPU schedulers always execute the job when they are scheduled on it. So you can write it as a point that the CPU scheduler executes the job when they schedules on it. So when does the processor executes the job? It's execute the job whenever it has to be scheduled on it if we really wanted to execute it. Now in Uniprocessor system, what is Uniprocessor system? Uniprocessor system is a system means which is having uni means one. So Uniprocessor system is a system on which the one job can execute at a time. Any other job must wait in the ready queue until the CPU is free and can be released. So as the word itself implies, what is uniprocessor? Uniprocessor. What exactly happens in uniprocessor? As uni means one. So what exactly happens in the uniprocessor? Only one job. You can say that only one job can execute at a time. Any other job must wait in the ready queue until the CPU is free and can be released. So we are discussing about uniprocessor. As the name itself implies, uni means one processor. So uniprocessor, what exactly happens what is the disadvantage of uniprocessor is that only one job can execute at a time. And when the execution is actually going on and another job is being assigned to it, then the job which is assigned to, the second job which is assigned to it has to wait until and unless the first job that is actually running on it get finished. Right? This is clear. Now, where exactly it is wait? In a ready queue. See, there is a queue in which suppose this is one job number 1. This is job number 2. Right? So, this job is already running in a processor. And the second job comes. So, until unless the first job that is already running in the processor doesn't finish, you cannot execute the second job. It has to wait. Where? In the ready queue. For how long it has to wait? It has to wait until unless this first job get finished or processed. Right? This is clear. Now, the another terms that comes into the existence is multi-programming. You know what is multi-programming? Multi-programming is performing multiple tasks at the same time. So the objective of multi-programming is to have some job running at all time that means maximum utilization of CPU, that is Central Processing Unit. See, what is the main objective of multiprogramming? We know that when we are talking about the uniprocessor, we can execute only one job at a time, and second job needs to wait until unless the first doesn't get finished. And where exactly it waits? It waits into ready queue. Now, when we are talking about the multiprogramming, means doing multiple jobs at the same time, the main objective of the multiprogramming is to have some job running at all the time. That means there is a maximum utilization. The CPU is utilized maximum in this case, right? So let's consider a few terms, that is Fcfs. Now, what does this word Fcfs implies, or what is the full form of FCF? Fcfs stands for first come first serve. First come first serve, right? Now, whenever have you ever understood the word, or you have studied this in the data structure, FIFO? You have in your prior classes, first FIFO and LIFO, first in first out, right? So FIFO, you understand, the most basic scheduling policy is first serve first come first serve, and is called first in first out, FIFO. This is first in first out. So what exactly, if you have to give the example of first come first serve, then have you ever seen in the bus stop there are the queues, and whenever you go to some bus stop and you have to go to some destination, in order to reach that destination you have to get into the bus. So what exactly happens over there? You form a queue. The person who's standing in the first position of the queue always get inside the bus at the first position. Let's suppose there are queue. See, suppose if I have to see, this is the bus. Suppose this is a bus, right? Let's consider it a bus only. And these are the number of people that are ready to get inside the bus. Now, this is the person who come first. This is come second. This come third. This come fourth. This come fifth. So these are the various, consider the people. These are the various people who stand in a bus stand in order to get inside the bus to reach certain destination. So the person who came first, the person who is at the first position in a queue get the chance to get into the bus first. So that's what I'm just trying to make you understand, that FIFO, first in first out. The person who comes first get inside first. The person who comes second get inside second. The person who comes third get inside third. The person who gets fourth get into fourth. So it depends totally and absolutely on the arrival of that person. If the person comes first, it will be served first, then it will get inside first. If the person comes second, the person will get second. So it's just a general example via which I'm just trying to explain you what exactly the first come first serve stuff is all about. Now, if we have to write the first come first serve, what does it depends upon? It depends upon the concept of FIFO. So you can write it, the first come first serve criteria. You can write criteria, algorithm, you can say algorithm depends on FIFO, which I have already explained you, first come first out. Now, what is the nature of FCFS, that is first come first serve algorithm? What is the nature of that? It is preemptive in nature. It is preemptive in nature. Is it preemptive in nature? No, it's not preemptive. Is it? No, it's non-preemptive in nature. So FCFS is the non-preemptive in nature and will have a negligible amount of the context which is as a job, right? So it is having almost negligible, you can say that nature and will have a negligible amount of context switching as a job. That means what does, if we say the word that it is having negligible amount of context switching as a job, or if we say it is non-preemptive in nature, what does it means? It means that once the job is scheduled on the CPU will not be released it until its completions, right? So until this, first we have, suppose we have given some job to to be scheduled on the CPU, so it's not going to be released until and unless it is complete. Once it is complete, then only it can be released. Otherwise there is no such method via which in case of Fcfs we can remove the job from scheduler or CPU, scheduled CPU. So what does it mean, switches as a job? It means once the job is scheduled, on CPU, will not release it until its completion. Right? So this is clear. So it is preemptive in nature, that is once the job is being scheduled, some task is being scheduled on the CPU scheduler, it cannot be released until it is completed or until unless it is finished. Right? Now what does it means? It means that the lower control switches of n-1, where n is the number of job, if there are number of the jobs are 4, then the number of the contact switches will be 3. And with the FCF, the job that requests the CPU first is allocated the CPU first. Right? In case of the FCF, what happens? The job that requests CPU first, you can write it, the job that requests for CPU. That for CPU first will be allocated first. So unlike priority scheduling, what exactly happens in the priority algorithm? See, the job is being executed on CPU on the basis of priority, but whereas in case of this first come first serve, that is FCFS algorithm, what happens? The first job that reaches the CPU or comes to the CPU will execute first, and then the next job which is scheduled will be at that time the second job will be waiting for the first job to be finished, and once the first job is finished, then the second job will comes into the existence, that it will be getting to the CPU for execution. Right? So second thing that we have understood, this is something that we have understood very clearly. Now the second thing is that it is non-preemptive in nature, that is until the first job is not finished, the second job will not be scheduled. And the most important point to remember is that in case of Fcfs, which is based on FIFO, that is first come first out algorithm, the job that requests for the CPU first will be allocated CPU first, whomsoever the job may be. The request that comes first to the CPU will get the CPU first. Right? So this is clear. Now this is all about FCFS. So today we have discussed the FCFS algorithm in our class. That's all for today. Now in the next session we are going to discuss about short job first. Right? So thank you very much, and